All right, everybody look up here for a minute. So we're doing Lewis dot diagrams for these 7 and then doing the binary and other ionic compounds. So I'm going to go ahead and do these real quick. Here. Most of you guys should have had this done right. One error that I've seen is that people will write their dots like above, like that, instead of off to the side. They need to kind of square the atom. All right, so that one. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So most people did that right. And which one of these is not going to bond with anything? Argon. All right, argon is not going to bond with anything. So as far as doing my ionic bonds, I can kind of scratch out argon. Now here's a shortcut to learning how to do this, all right? And this is how I still do these today. Like if I'm writing a test or making a key for a test or whatever, is just put the metals with all the non-metals, and that really limits the options. There are really only 9 possible answers even in this, all right? So take calcium. It's a metal, right? It's on the left side. So if I want to try calcium with fluorine. I want to try calcium with phosphorus and calcium with sulfur, right? Those are the only 3 non-metals, right? Yeah. And then my next metal is sodium. I could do sodium with fluorine, sodium with phosphorus, and sodium with sulfur. That's the only 3 non-metals. And the last one's aluminum. I could do aluminum with fluorine, aluminum with phosphorus, and aluminum with sulfur. Those are the only 9 possibilities, even remotely possible. Does that make sense? Because I have to have a metal and a non-metal. All right? And so there's 7 answers. There's only 9 that I could do a metal and a non-metal together. Does that make sense? So the easiest way for me to start doing these, even still, is to go, okay, I need a metal and a non-metal. So calcium with the 3 non-metals, sodium with the 3 non-metals, aluminum with 3 non-metals. What can I make work? All right? So jump back in there, take a few more minutes, and see if this helps you at all. If you're struggling, see if this helps you at all. So really all I got to do now is see if these match, or these match, or these match. All right? Keep going. Let's go over these. So I'm going to start with sodium, because sodium's the easy one. It's a good way to kind of work our way in. So sodium and fluorine. Sodium has 1 extra valence electron. Fluorine needs 1, so that's easy, right? NaF. So that's a binary ionic. NaF. And what are my charges? What are my oxidation numbers? Plus and minus. This is sodium fluoride. Sodium fluoride. We did that one. What other binary ionics can I go ahead and do? So what I need to give away the number I need to receive, right? And so what else do we have like that? What about calcium? It needs to get rid of 2. Is there anything it needs to? Sulfur. All right, I can do CaS. And what's my charge on calcium? 2 plus, and sulfur is 2 minus. That is calcium sulfide. All right, there's nothing else that needs to. What about aluminum? Is there anything aluminum can go directly in a 1-to-1 with? Phosphorus. It can donate 3 to phosphorus. So AlP, that's 3 plus and 3 minus. Aluminum phosphide. So those are my 3 binary ionic compounds that I can make. Most of you had that right on your paper. That's pretty simple. We're just trying to get to 8. So where can we get this? Something with 3 or less, something with 5 or more that we can donate back and forth to.
Pardon me, can you send Brittany Ashley to the main office?
Yep. All right. So now let's continue on. What about this one? Calcium and fluorine.
Yes.
How? Calcium needs to get rid of 2, fluorine needs 1.
So you do 2 calcium and then 2 fluoride.
1 calcium and 2 fluorine.
Yeah.
CaF2. And what's my charge going to be on calcium?
2.
And F minus calcium fluoride. Calcium fluoride. So got that one done. What about this one?
Yes.
Not very well, because if I give 2 from calcium to phosphorus, what's wrong? Phosphorus still needs one more. Well, I give another one from calcium, then I have an extra one on calcium. Right? Does that make sense? It's kind of a chain. You end up with 5 atoms, really. All right? So, in theory, we can do that. Not right now. All right? So, skip that one. That's one that doesn't work. All right? NAP. Phosphorus needs 3. Sodium needs to get rid of 1. What do we have to do? How many sodiums? 3. Na3. Na3P. And that's a plus and a 3 minus. Sodium phosphide. And what you'll find is that things that need 1 valence electron, the things that need to get rid of 1 valence electron, can bond to a lot of things, right? Because it's so easy to give and take electrons. Notice halogens, alkali metals are the most reactive groups of elements, right? Should make sense to you. NaS. Sulfur needs 2. Sodium needs to get rid of 1. So Na2S. Sodium sulfide. And aluminum and fluorine. Aluminum needs to get rid of 3. Fluorine needs 1.
Does it mean you have to have 3?
You gotta have 3 fluorines. AlF3. AlF3 and Al is 3 plus. It's a little writing, sorry. And F minus, aluminum fluoride. Okay. And then we do have one left that we could try. Obviously, we have all the answers if this is a test, and I have all the answers. Now, there are times where on a test, I'll give you, there might be 10 possibilities, and I say, give me 5, or give me 4, or whatever. Just for time's sake, not make it do. If you can do 4, you can probably do them all. ALS, also known as Lou Gehrig's disease. ALS, aluminum sulfide. Can we do this? What happens? I have 3, and I need 2. I give 2, I have an extra.
So
We end up in that. Yeah.
3.
Right. We end up in the same kind of boat that we were with that guy, right? It's messy. It's 2 and 3 on both of them. All right. So those would be the 7 answers I was looking for. All right. In this, what is the cation? Na, it's the positive, right? And the anion, fluorine. The cation is always going to be the what? The metal. And the anion is going to be the thing receiving electrons, the non-metal. All right, the cation's always first. It's the metal. The anion, the non-metal, is going to be second. Get the negative charge. Okay. Next thing. Let's throw this guy into the mix. Copper 2. Look at your periodic table. Copper can have 2 different charges. We have copper 2 or copper 1. So we're dealing with the one with more electrons. The transition metals are weird, and they have weird numbers of valence electrons that they need to get rid of. All right. So if you look at that table again, like for instance, look at titanium. What's titanium? 4 or, right? So we have weird charges on these, all right? And this is just really telling you how many electrons they need to get rid of to be stable, all right? So copper is copper 1 or copper 2. We just write it like this with the Roman numeral after it. So let's say we have copper 2 thrown into this group of atoms that we're trying to see what will bond with what. Copper 2, all right? Copper 2 is going to behave just like what other element here? Calcium, why? 2 valence electrons to get rid of. So copper is going to do anything that calcium can do. Do you guys see that? All right. So I had a binary compound there with calcium and sulfur.
Replace calcium with copper?
Basically, yes. Binary ionic compounds. I can do CuS, and that's 2 plus and 2 minus. Now, naming this gets a little trickier because I have to know which copper I have. So I'm going to write a little note here. Naming ionic. Naming ionic with transition metals. Naming ionic with transition metals. So the new way of doing this, which is easier, which you'll like, we're just include oxidation number as a Roman numeral after the metal. All right, so this is just going to be copper. Sorry, I'm in the way. Include oxidation number as a Roman numeral after the metal. So all we do is copper to sulfide. That's it. That's easy, right? We just put the Roman numeral of the charge after the metal, so we know which copper we have. There is an old way to do this, and the reason I include this, nobody really uses this anymore unless maybe you have a really old professor or something. Nobody uses this except for, there are a lot of famous compounds used in medicines or whatever that have an old name, and we keep using the old name because it's still there. Sorry. So here's how this works. Add. Yeah, I forgot about it. Add us to the end of lower charge. Add ick to the end of higher charge. Use Latin where possible. Now, I'm going to tell you something before I show you this. I don't expect you to do this in this class. It's outdated. However, I want to show it to you so that when you see medicines, you know what it is. So some of you might be on an iron supplement. Maybe you're anemic. Maybe you're pregnant and your doctor told you to take an iron supplement. I don't know. But that's probably going to be in the form of like ferrous sulfate. And so why is it called ferrous? I don't understand. It's an iron supplement. Why is it ferrous? All right. Well, that's because it's got an old name attached to it, and we don't change it because it's a medicine. So we're not going to change it now because people have been taking it for years. All right. So this is the old way of doing it. I don't expect you to do this. If you write it on a test, I'll take it. It's still correct on a test for me. But this is.
What do you exactly mean by using Latin?
I'll show you. All right. So copper, for instance, is this the higher or lower charge? It's the higher. It can be a 1 or a 2 when we're using the 2, right? So we're going to use ick, right? Now copric is not the appropriate name. It's cupric. All right, because it comes from cupric. So cupric sulfide. And if I had this compound, let's say I had Cu, if I did copper 1, if I had Cu2S, what would that be? That would be cuprous sulfide. Cuprous sulfide. All right? So, again, higher charge is ick, lower charge is us. All right? Now, where this comes into play, all right, the Latin. All right, so if we have iron, it's ferric and ferrous, not iron. All right, gold, auric and auris. All right, so ones that have, a lot of times they're the ones with weird letters. You're like, why is it Fe or why is it Au or why is it, right? We're going to use the Latin name that goes with it. All right, but we don't, again, I'm not going to require you to do this. I want this, just with the Roman numeral, but I wanted to make sure you're aware of it so you knew when you see it. All right? Now, we have one last thing to add today. One last thing. We still got 20 minutes. It's all right. Polyatomic ions. All right, polyatomic ions. I'm going to move this camera over here a little bit. Polyatomic ions. Polyatomic ions. Really not that difficult. Hopefully you guys don't freak out about it. Polyatomic ions. Poly means what? What is somebody who is a polytheist? More than one God. Polytheist, more than one God. Polymorphism, more than one form. All right, so polyatomic, more than one atom, ion, charge, right? More than one atom is charged. Polyatomic ion. All right, this is a group of charged atoms. Group of charged atoms. Now, I'm making you memorize 16 of these. You have to memorize, I think, 17 in AP Chemistry if you take that your junior year. Almost all of them overlap. There's, I think, 12 are the same. So if you learn them now and you eventually take AP Chem, you'll be a major head start. In AP Bio and Bio, you don't have to memorize any. But there are a lot that you're expected to be able to reference pretty quickly. And so it's still a useful thing to have in your pocket. All right? So, polyatomic ions, look at the top of your periodic table. There's a big set of them. Again, I'm only making you know 16, but you have a big chart of them on top of your page. All right? So I'm going to start with, I'm going to erase this side here. I'm going to start with cyanide. All right? Why am I blind? There we go. Actually, you know what? Let me go back to this list of elements I just erased. All right, let's use sulfate. I'm going to use sulfate. SO4, 2 minus. That is sulfate, right? Out of the elements I just had, what would it bond to? What would it bond directly to? How many electrons does it need? 2. What did we, huh? Calcium. CaSO4. 2 plus, 2 minus. And if we include this copper, right? Cu2 plus, SO4, 2 minus. What else did we use? Sulfur, right? Where else did we put sulfur with? Na2, SO4. Anything that sulfur was doing, sulfate can do, right? Does that make sense? Because it needs 2 electrons. It's a group of atoms behaving as a cluster, behaving together, gaining or losing electrons. All right? And we would just name these very simply. Calcium, we just keep the name that we've given it. Sulfate. What was this one going to be called? Copper 2 sulfate. And sodium sulfate. So if we were to add sulfate to this group of things we had here, these would be the 3 compounds we come up with. Now, are these binary ionics? Because I just used calcium and sulfate and copper and sulfate. Are these binary?
No.
Why not?
Because it's not 2.
It's not 2 atoms. Even though it's behaving the same way, it's more than 2 atoms, so it's not binary. Right? You guys, does that make sense? So these would just get added to this list down here. Just like anything else I would have put copper with. Copper fluoride with 2 fluorines. Copper 2 fluoride. All right. One last example. This is a little bit trickier. What about those 2 atoms? That atom and polyatomic ion. I have gold 3 and cyanide. gold 3, and cyanide. That's easy to bond, right? What do I have to do? If I give an electron from gold to cyanide, what's the problem? I have 2 more, right? So how many cyanides would I need? 3. I would need 3 cyanides. Now, it gets a little tricky though. So Au, 3 plus, Cn, how many cyanides do I need? What happens if I put a 3 there to show I need 3 cyanides? What's that look like? Ben? Huh?
I was writing that down, I wasn't paying attention.
Why is this wrong, Katie?
Because it now looks like you have 3 nitrogens.
It looks like I have 3 nitrogens, and that's wrong. I need 3 cyanides. So in math class, how would we do that? It's like foiling, right? 3 cyanides. Good question. I didn't leave much room for it there. Cn minus, I have 3 of them. And this is going to be called, what's it going to be called? Aluminum. Gold. Gold 3 cyanide. Or auric cyanide. Either of those would be correct. And that is a really expensive way to kill someone. Say where? I haven't tried it. Experiment. All right. Now,